Hello, my name is Derek Smith and I'm part of Group 7, and we will be introducing and completing a problem dealing with impulse responses. The impulse response is a system's response to an impulse, the impulse being a delta function. We need to discuss a system. A system starts with an input signal, x of n. X of n passes through the system and outputs y of n. The system is known as h of n. H of n is the impulse response. Now, this only works if the system is a discrete linear time invariant system.
So here we have our difference equation, y of k minus 1 minus 2yk plus 2xk plus 4xk minus 2 equals 0. So here we isolated the y of k on one side. And now we've divided everything by -2. So it's now y of k equals 1/2 yk minus 1 plus x of k plus 2x of k minus 2. So we'll now start plugging in our values from 0 to 4. So our first one will be y of 0, and that'll make it equal to 1/2 y negative 1 plus x of 0 plus 2x negative 2. We assumed our initial conditions for y to be equal to 0, so this first term will go to 0. X is evaluated at the delta function, so that will be 1, and x negative 2 is the delta function at -2, which is 0. So y of 0 will equal 1. Y of 1 we do like we just did before on y of 0, and we'll get 1/2. Following the similar steps that we just did, y of 2 will equal 9/4. Y of 3 equals 9/8. And finally, y of 4 will equal 9/16. And since this is the impulse response we're finding, our final answer will be h of k equals 1, 1/2, 9/4, 9/8, and 9/16.
Just to reiterate, we have a discrete linear time invariant system here. We have our input signal, which is what we call x of n right here. Then it goes through a system h of n right there, and then has our output of y. And we can use this also to get output of this system where y is equal to x convolved with h to get our output. Another way mathematically to do it.